Hello my fellow CAD lovers, and welcome to the third part of this tutorial on modeling a spiral casing in Autodesk Inventor. In the first part, we create the center line of our main case, and we add in part 2 additional geometry from where we derive all these work planes. In this third part, we are going to create the cross-section curves. The cross-section curves are depicted here. As you can see, there is nothing fancy, just a bunch of arcs with increasing radius. But since the sheet metal components we will create from these cross-section curves will be later trimmed to make room for these two rings where they will be fitted and welded, we will have to draw them slightly oversized so that we are sure to always have enough room for the rings. And we are going to do basically the same things for all the sections, except for this cross-section curve 16, where the sheet metal components and the deflector meet. We will have a different geometry. So this is what we are going to build for that one. Okay, so now back to Inventor, and we are going to start with this work plane WP1. So to create our sketch this time, we are going to click on the plane, then move and select create sketch. The view is aligned with the sketch plane, but we cannot see what we are doing, so we are going to rotate so that we are looking from a position like this, and we will start the 3-point arc tool. The first point will be this one, somewhere like that, and the second point like this, and then we are going to drag and click somewhere like that. Okay. To fully define the sketch, we will use this point as the center point, and the end point of this line will define the radius of the arc. So we are going to use the project geometry tool and project the line into our sketch. And now, in order to see what we are going to be selecting, we are going to hide this sketch, so we will toggle off the visibility. Now we are left with a clean graphic area. We are going to drag this down a little bit like this, and before we connect this center point to the end point of the line, we are going to add two additional lines. So this one to the center of the arc and to the end of the arc. Okay, next we will add a dimension to define the opening of the arc. So we will enter opening angle is equal to 15 degrees. Okay, now we will select this endpoint and drag this like this, so we are okay. It's a little bit silly, we are getting to nowhere. Okay, so first we are going to connect this endpoint to this one, then this endpoint to anywhere on the arc, and now we can drag this and bring it to the center like this. And to finish, we will add a symmetric constraint. So the first line this one, the second this one, and symmetric about this. These two lines will be made construction, so construction. And that's it. The first sketch is done, and we will finish the sketch and then rename it 0.1. Now that we have the first cross-section curve built, we will have to do the same operation 18 times, and we don't want to have to build the same arc and two lines and same constraint all the time. So what we are going to do to make our life easier is to copy this sketch. So we are going to move and select the sketch, then right click and copy. Next, we select the work plane number 2, then right click and paste. As you can see, the sketch is pasted onto the second plane. And we can do the same for this third one. So paste, and again paste, and you can see that the orientation of the plane is consistent, and this is because in part 2 we make sure that the normal direction of the work planes are consistent. So that's why we are getting the same consistency between the cross-section curves. Okay, so now I'm going to keep pasting. So paste. You have to make sure that you select the planes before clicking on paste. As you can see, I didn't properly select this plane and I click paste. Now you can see onto the same plane I have two sketches. So I'm going to delete this one and make sure I select this and paste. Again, select this one and paste. Okay, I'm going to keep doing that until I have all the sketches in place. Okay, now you see I made a mistake again. Make sure that you select the plane, not highlight the plane, because if you just highlight the plane, the previous plane will still be the active one and the copy will be on the previous plane. So make sure you click on the plane and then paste, select, paste, select, paste, and there we go. Pasting sketches around and around. Done. We have all the plane created. As you can see, it was very easy. Cross-section curve are done and second part of the tutorial is over. Not really. There is some more job to do, and the first clue is the color of these sketches. As you can see, the arcs are bright green, and this means that the sketches are not fully constrained. So we will have to get inside each of them and add the missing constraint. If we toggle on the visibility of this sketch, we can see that the size is not the proper size, so we'll have to correct that too. Okay, so we are going to start with this one. So now we will edit the sketch, and as you can see, each time we enter the sketch, the view is aligned with the work plane, and this is not really desirable for this tutorial. So we are going to exit the sketch and make sure that we turn off the settings which is responsible for this behavior. And to do so, move to this tools tab and select application option, and in the sketch tab locate this look at sketch plane on sketch creation and edit, and click to deactivate the option. Now to finish, select this button OK to finish. Now when we will enter a sketch, the view will not be aligned with the work plane. Okay, so now we can see that the sketch is not properly constrained, so we are going to add the missing constraint. The first one will be this for the endpoints, or maybe the center points of this arc to this one. I am not quite sure. Okay, so we just have one constraint to add. So the endpoint of this line we will project onto the sketch to this endpoint, and the other one will define the radius as we did for the previous sketch. So right away, project geometry, the line onto the sketch, then hide this and add the constraints, the constraint we need. So this and this to that, and the symmetric constraint is preserved, none. So this line, and this line. For the angle, we could add this, click on this button and select list parameters, and from there we will select opening angle. So for this sketch I will link the value of the angle like this, but for the other ones we are going to do it differently. Okay, so we exit the second sketch and right away we jump in the third sketch. And maybe something I will do beforehand is to hide all these cross-section planes. So I will turn off the visibility, so you'll have a graphic area less cluttered. So next, this one, and we show visibility, project this line, escape, hide the sketch. Now if you grab this, we can move it, so we will still have to add the constraints. So this to that, and this to that, and then the symmetric constraint. I think you grab the gist of it, so I will just go on until I reach sketch 16, where the geometry will be, not this one, but this one, where the geometry will be slightly different and it will not be something exceptional. So okay, let's keep doing. So this to this, and let's see, can I move this? Okay, this to that, and now I will move this like so. Then symmetric between this and this, then close. Next one. For this last sketch, we are going to project the endpoint of this line and the endpoint of this other one. Visibility, and we will also need the line anyway, so project this one also, visibility, then this, oops, so this to this and this and this to this, and finally we will add the symmetric constraint, so this and this to this. Okay, maybe do I miss something here? Did I? Okay, good. So maybe I should measure this to make sure that I snapped onto the, so this should be 350 and it is okay. So finish sketch, and we have sketch 16 to do, so I will go back to this one, and same as for the other one, I will show the WP location sketch, then project this line and hide this one, and the usual thing, so we will snap this to that and this to this, and then like so. And what we want to do is to make this dimension driven first, so we will right click on the dimension, then select driven dimension, so that we can bring this back like so. And maybe we'll add the symmetric constraint, so between this we'll bring this back like so. Then we will add the two lines at 37 degrees from this one, and we will have an opening of 380. Okay, so now the line tool, so we'll select the endpoint and make sure we have an effect tangency, something like this, then another one like so, and a third one to this endpoint. We will add a tangent constraint from this to this, and we make sure that this line is vertical. I don't know. Okay, vertical. Yes. Okay, next we will add this 37 degree angle, and to finish we will add this, which is the deflector length. So we will add the formula like this: deflector length, which is equal to 380. Length is not properly length. Okay, so and enter. Okay, now this should be construction, and now we can exit the sketch, and voila, we have all the cross-section sketches for the main case in place. And to finish this part of the tutorial, all we have to do is to rename our sketches. So this one will be 02, this one 03, this one 04, and oops, escape, 05, 06, 07, and so on and so forth and so on. Okay, so this was a very boring part, and for the next part we are going to start building the 3D components. We're going to jump in the 3D environment and we will create our assembly and build the first 3D components, and these components will be the rolled sheet metal components for the end case. So hope to see you then, and thanks for watching again.